Everyone, welcome to example number 1 on Thomson's experiment. These next two lessons actually have us doing a lot of balancing of forces, which is a very important concept in physics 30, and understanding which two forces that you balance so that you can set their equations equal to each other and solve for what you're looking for. Well, with Thomson's, you either balance electric force with magnetic force, or you're going to balance magnetic force with centripetal force. And the way that you'll kind of determine that is based on whether something passes through undeflected, that's going to be the electric force and magnetic force, or whether it's bent through some sort of radius, then you'll be talking about the magnetic force and centripetal. You have these forces scattered throughout your formula sheet. The centripetal forces are with your kinematics and dynamics section. The electricity force we've worked with back in Unit 2. Magnetism we worked with in Unit 3. This is a good concept that helps tie a lot of different things together in terms of this experiment. And by the way, there's a lot of questions on Thomson's experiment that tend to show up on diploma exams, both in multiple choice or written response. So these examples kind of give you a heads up of what to expect. Since this thing is passing through undeflected, we have a electric field. So I'll write that down here as 5.70 times 10 to the 4 newtons per coulomb. I have a magnetic field here of 2.90 times 10 to the negative 2 Tesla. We're looking for velocity. So if it's going to pass through undeflected, start with the two forces that are going to be balanced. So we know that Fe in between parallel plates is electric field times charge off our formula sheet, magnetic force of a charged particle, Q V B. The charge actually divides out on here. It's on both sides of the equation. So the velocity will be equal to the electric field divided by the magnetic field. We're given both of these numbers, 5.70 times 10 to the 4 newtons per coulomb, divide by the magnetic field strength, 2.90 times 10 to the negative 2 Tesla. Punch that in your calculator. And you get 1.97 times 10 to the 6 meters per second. And that's a reasonable speed for these types of voltages that you're working with in the Thomson experiment. So really look for what you're given in the question. Then you set up the appropriate force formulas. There isn't just a section on the formula sheet that just says use this formula for Thomson. You have to build it using previous formulas you've worked with in Physics 20 and in the first 3 quarters of Physics 30.